sometimes we might have an algebraic expression that codes for a certain thing, say something like x plus 4, say, something fairly generic. But we might want to consider not just one lot of that, but in fact, say, two lots of that, x plus 4. Now, one way that we can think of that is to say, well, what is here altogether? Well, there's an x and there's an x, so fair enough, that's two x's. And then there's a plus 4 and another plus 4, and if we were to put those together, we would get a plus 8. Perfectly fine. Now, the other way we could think of it is we could say we've got two lots of x plus 4, as in we've got, and we can think back to our BODMAS kind of stuff for this. I'm going to put these in brackets just so they are contained. Well, if we've got two lots of that x plus 4, surely that's the same as us writing two lots of x plus 4. We've got 2 times the x plus 4, because the x plus 4 is a contained single thing. These are both ways of describing exactly what is there, so I could put an equal sign in the middle because they must be exactly the same. They're just different ways of describing the same thing. Now the thing is, there's one more thing we can do with this when we think about algebra. Does that there really need to exist? Because when we're talking about algebra, if we're writing things like 2x or 5x or 7y or whatever, we are dropping out that times sign in the middle whenever we're having numbers and letters next to each other, or whenever we're having letters and letters next to each other. So we can, in fact, get rid of that and just write the 2 directly in front of the bracket. Now, they are just different ways of writing the same thing. This form is called the expanded form, and this one is called the factorised form. Expanded form, one that doesn't have brackets in. Factorised form, one that does have brackets in. They are two ways of writing the same piece of information. What we need to be able to do is we need to be able to switch between the two comfortably. So we're going to have a look at going this way first. We're going to have a look at starting with the brackets and shifting into the thing that doesn't have the brackets. So we're going to go back to we're going to start with the 2x plus 4 again, because we kind of already know the answer to that, the two lots of the x plus 4. So if we start off with this, two lots of the x plus 4. Well, okay, fair enough. That would be us saying there's an x plus 4 and there's an x plus 4. And altogether, that's going to come to, I'm going to write that differently. That's like saying we've got an x plus 4 and another x plus 4. Altogether, that's 2 x's. A plus 4 and a plus 4 gives us a plus 8. Fine. We could try that with another type of thing. We could start with something like this, say. 3 lots of y plus 10. Well, y plus 10, y plus 10, y plus 10. What have we got here? We've got 1, 2, 3 lots of y, so 3y, a plus 10, a plus 10, and a plus 10, and if we were to put those all together, that would give us a plus 30. Fair enough. That's what's here. Nothing fancy going on. We're just writing out 3 copies of it because that's what's told us. That's what it's told us to do in front of the bracket. There is a times there. We can't see it, but we know from the algebra, from the simplifying that we did a couple of weeks ago, that that times has been dropped for neatness. We could think of one more example, just because this might help solidify what's going on. 4 lots of something, this r minus 5. We don't know what r is. R, remember, is a particular number, same as y, same as x. We don't know what they are. We're probably never going to know what they are, but it doesn't really matter. We've got this value, this quantity r, we're taking away 5 from it, and then we've got 4 lots of whatever that is. If r is a number, r take away 5 must also be a number, remember, and then we've got 4 lots of that. Well, let's write them out over here. R minus 5, r minus 5, r minus 5, and r minus 5. I mean, you can probably guess where this is going anyway, but we've got 1, 2, 3, 4 lots of r, so 4r, and a minus 5, another minus 5, another minus 5, and then another minus 5, and altogether that's minus 20. Now have a look at the bracketed form, the factorised form, and this form here. How have we got from this one to this one? Well, hopefully by looking at it, you would notice that certain things have happened, and what we've effectively ended up doing is going 2 times the x to give us the 2x, and 2 times the plus 4 to give us the plus 8. Let's see if that works with the next one, because if that works with the next one, then we may well be onto a pattern here. 3 times the y does give us 3y, and 3 times the 10 does indeed give us the 30, noting that it's a plus 10 and a plus 30, so the symbols match up as well. And finally on this last one, 4 times the r will give us 4r, and 4 times the minus 5 to give us a minus 20. Remember that 4 times 5 is 20. We've got one minus sign, so one change of direction would be expecting to head up the number line. One change of direction sends us down the other way, and we end up with a minus 20. Now that process that we've just gone through is a process known as expanding. Starting with something that has brackets in and getting rid of the brackets. The basic idea being that you start with the thing that's on the outside of the brackets and you times that by each of the things inside the brackets in turn to get your expanded form. Notice that these two are exactly the same, they're just written in two different ways. So expanding, start with the thing on the outside of the bracket and times it by each of the things inside the bracket in turn to get the thing on the outside of the bracket. So question, this is another one of our clue words, our keywords in questions that we're going to look out for. So the question would be nice and simple, expand. If we have a look at, first of all, well, let's go for a simplish one, 4, and then in the brackets, x take 6. And then we'll do 2y, we'll start to throw in some extra letters here, and then y plus 3. And then we'll do one final one, let's go 4a, and then in the brackets, 3b minus a. Okay, so for each of these, it doesn't matter what's outside the brackets, it doesn't matter what's inside the brackets, or in fact how many things there are inside the brackets. For each one, we take the thing that's on the outside of the bracket, and we times it by each of the things inside the bracket in turn to get our expanded answer. So for the first one, I'm going to start with the 4, we're going to times it by the x, and 4 times x will give us 4x. For our second term, we're going to do 4 times the minus 6 this time, remembering that it is a minus 6. 4 times the 6 will give us 24, and the minus 6, in fact, will make it minus 24. And there is our expanded form. The second one, doesn't matter that there's letters on the outside, it still works in the same way. We're still going to take whatever's on the outside of the bracket and times it by each of the things inside the brackets in turn until we get our final answer. So we're going to start with the 2y, and we're going to times that first of all by the y. Well, 2y times another y will give us 2y squared. The y times y will give us y squared, and the 2 will happily sit in front of that. We're then going to look at the second term, because we're timesing the thing on the outside, times each of the things in the brackets in turn. 2y, and then we're timesing that by the plus 3. So 2y times 3, that will give us 2, 4, 6y, and then plus 6y because it's a plus 6, because it's a plus 3. And there is our expanded form. 2y into y plus 3 expands to give you 2y squared plus 6y. And then for this final one, a little bit more complicated because we've got a couple of different letters going on, but it shouldn't really matter as long as we can do the thing on the outside times each of the things inside in turn. So first of all, we're going to do 4a times 3b. Well, remember, we can write that in any order we want. So what we're going to do is we're going to pull the numbers to the front, and the 4 and the 3 are going to multiply together to give us 12. Then we can have the a sat afterwards and the b sat after that, noting that we've dropped the times symbols out from in the middle of that. 12ab. And then for the second bit, we're going to do 4a times the minus a. Well, if it was just 4a times a, it would be 4a squared. And we're going to need that minus sign coming from the minus a. And there is our factorised form being expanded to make this version here. Notice in particular that the signs generally match up. They may not necessarily always be the same, but often they will be, particularly if the numbers on the outside of the brackets are positive ones, like in all three of these cases here. Once you start having negatives outside and inside, things can start to get a little bit more complicated, but generally speaking, you will have signs matching up in a lot of cases. The other thing to notice, how many things are there inside the brackets here? Well, there's 2 here. There are 2 terms in the answer. 2 here and 2 terms in the answer, and 2 here and 2 terms in the answer. If you have 3 terms inside the brackets, you will have 3 terms in your answer. 4 terms inside the brackets, 4 terms in your answer, and so on. Because expanding it every time is going to be the thing on the outside times each of the things inside in turn to give you your expanded answer. Now there is one addition to this, where they could, in these questions, throw in an extra keyword for you. We still have this keyword expand, but we could also have expand and simplify. It's best to just have a look at a question with this and get used to how it might work. So we'd start off with something like this: 3p minus 6 plus 4p plus 5. Like that. So 3 into p minus 6 plus 4 into p plus 5. So what we're going to do is we're going to follow these instructions first by expanding, and then after we've expanded we're going to think about simplifying. So we're going to expand first of all. I'm going to cover up this second part of the question. I'm not going to look at that. I'm just going to look at the 3p minus 6 first of all, and I'm going to expand that. So in fact, let's actually cover up the second part of this question. Let's just look at the 3p minus 6. So if we expand that, we're going to get 3 times p is 3p, and we're going to get 3 times the minus 6 is minus 18. That bit is done. We've dealt with that one. So we're now going to cover up the first part of the question. I'm going to just look at the second bracket on there. We're going to do 4 times p is 4p, and we're going to do 4 times the 5 is plus 20. But there was one thing I didn't take account of, and it was that symbol in the middle. We must be careful with this. If we are doing plus 4 times the p will be plus 4p, and plus 4 times the plus 5 will give us plus 20. If that is a minus in the middle, you must treat it as a minus. Moving that, we now have the whole question there. So we now have 3p minus 18 plus 4p plus 20. What we can now do is we can simplify that. We can ignore everything in the first part of the question. We can box these off into our different bits so that we are keeping the signs stuck to the things they should be stuck to. We can then move our cards around, so we've got the 3p and then a plus 4p, and putting all the p's on one side of the board. On the other side of the board we can have the minus 18, and then we can have our plus 20. Collecting these together into one card, 3p plus 4p is going to give us 7p, and the minus 18 plus the 20, minus 18 plus 20 would take us up to plus 2, so our final answer is going to be 7p plus 2, and that is us expanding and then simplifying. Okay, so we have a go at another one of those. We'll have a look at one with a minus in this time, just to make sure that we know how to deal with that. So, similar kind of question. Expand and simplify. Nice, clear instructions. 2 of our keywords there: expand, meaning get rid of the brackets, and simplify, meaning collect everything together that you can collect, write it as neatly as possible. Very similar to the previous one, but we'll go with x this time. So 2 into x plus 3, 2 lots of the x plus 3, minus 5 lots of the x plus 1. Now, if we're going to do this one, then we have to be careful with that minus. We have to make sure that we are going to take note of it. Otherwise, we end up either missing it and losing information, or getting signs on things wrong, which will change the way the question works. First part of the question does not change, though. We can still start with the first bracket, so we can cover up the second. We don't have to worry about that one. With the first bracket, we've got 2 lots of the x gives us 2x, and then 2 lots of the the 3, the plus 3 in fact, gives us a nice plus 6, and that one is dealt with. Now, for the second bit, I'm going to cover up that first bit, but I'm going to keep the sign attached to it, because now we're going to have to think about this not as a 5 lots of x plus 1, but in fact a minus 5 lots of x plus 1, recognising, of course, that the minus symbol and the subtract symbol are in fact the same one, just used slightly differently. So here we've got a minus 5 on the outside, and we're timesing that by the x. Remember, with expanding, we are timesing whatever's on the outside of the bracket by whatever is inside each thing inside the bracket in turn. So we've got the minus 5 on the outside, we're timesing that by the x. 5 times x will give us 5x, so the minus 5, 1 minus, 1 change of direction, minus 5x. And then for our second term, we're going to do minus 5 times the plus 1. Well, 5 times 1 will be 5, and again, 1 minus, 1 change of direction, so minus 5. And there is our finished bit for that step. 2x plus 6 minus 5x minus 5. I'll move that down a little bit so it's closer. Now the second step in the instructions told us to simplify. We've already done the expanding. We can now do the simplifying. So we're going to look at this. We're going to start from the right-hand side, same as we did when we did simplifying the first time. We're going to box off the 5 and the minus because they are attached together. The 5x and the minus in front of it, the 6 and the plus, and then the 2x at the front. I'm going to move all the x's to one side, and I'm going to move all the numbers that are on their own to the other side. So over here we've got a 2x in a box, and we've got a minus 5x here. And over the other side, we've got a plus 6, and we have got a minus 5. Over here, we've got 2x's take away 5x's. Well, you might want to think about your number line, you might want to count backwards, whatever you want to do, but that's going to end up giving us a minus 3x. On the other side, the number side, we've got plus 6, and then we're taking away 5. Plus 6 minus 5 leaves you with plus 1. We're going to need to write a symbol in there. It's not coming out as minus 1. It is coming out as plus 1, so we are going to write plus 1, meaning our final answer is minus 3x plus 1. You could be asked, I guess, to expand and solve, I suppose. So you could start off with something like this, where we've taken something that was an expression, but we've now made it into an equation by putting the equals on the end. Remember that an algebraic equation is any bit of algebra that is equal to something. Now this, yeah, we could deal with this unexpanded if we wanted. We could write this as a function machine. The problem is you might not recognize it as one. However, if we follow the first bit of the instruction, which is to expand, we'd have 10 times the y gives us 10y, and then we'd have 10 times the minus 4 gives us minus 40. That is still equal to 20, and looking at it in this way, that looks a lot more like a function machine question. You would recognize that as a function machine question. The question was nice to us and it said expand. Sometimes it may not, it may just say solve, but if you see something that has brackets in with the question, solve, that looks like this, that looks like you could expand it, it might be worth trying to expand it, because you might then be able to recognize what kind of solve question it in fact is. Looking at that, that is a function machine question. So we're going to build our function machine going forward. So we're going to start with the y. The first thing that happens to the y, well, remember, we're going to read the question out, and by reading it, we'll find out what happens to the y. 10y minus 40. So the first thing that happens is it becomes a 10y, i.e. we times it by 10. Then we take off the 40, and that spits 20 out the end of the machine. Reversing the machine, 20 goes back in. We're going to add the 40 this time because we're reversing it. Adding the 40 will take us up to 60. And then instead of timesing by 10, because we're going backwards, we are dividing by 10. So then we're going to spit 6 out of the end, and I'm reckoning then the answer y equals 6. We should probably check that somewhere. We should either check it in here, or in fact, as it might be better to do, check it in here. If y equals 6, then inside the bracket, which is where we're going to start, because we're thinking about BODMAS, we're going to do 6, take away 4, which is 2, and then we're going to times that by 10, which does indeed give us 20. And that is us expanding these brackets first, and then solving like we normally would for whatever kind of equation we end up with.